In this class, we'll see the system analysis with the help of Laplace transform. Again, the system may be defined in terms of differential equation. Then if that is the case, then d by dt we have to replace with s. D square by dt square means s square. D power n by dt n means s power n. This is true only when the system is not having any initial condition. Okay, if the initial condition is not there, okay, then we can use this replacement. Or otherwise, if they are giving some initial condition, okay, initial condition means value of some parameter output at t is equal to 0 minus, okay, or otherwise at t is equal to 0. Okay, if they are giving some initial condition, again we have to use this formula. Suppose if d by dt y of t is there, s into y of s minus y of 0. Again, the y of 0 may be some number. Okay, it's like a number, or it may be 0 also in some cases. Okay, then d by dt y of t means s into y of s minus y of 0. Then if it is a second order differentiation, d square yt by dt square, then s square y of s minus s y of 0 minus y dash of 0. Okay, again, now in this case, they may be mentioning both the value, both y of 0 and y dash of 0, or otherwise any one of these may be 0. This may be y of 0 may be 0, or it may be non-zero, or it could be anything. Just this is the formula once if we are provided with the initial condition. So in the generalized manner, okay, we can write like this: for higher order differentiation, d power n by dt n y of t is equal to sn y of s minus s power n minus 1. That means one order is reduced, then y of 0, then s power n minus 2, but not y of 0. This is y dash of 0, and then minus s power n minus 3, then y double dash of 0. Then it goes on like this. This is the generalized formula, but it is enough for the exam point of view. Mostly we will be getting the differential equation either with the first order or with the second order almost. Okay, or otherwise it's always better to remember this formula. In some cases, if they are providing with higher order differentiation, then also we'll be able to solve this. So next, okay, now we'll try to solve the questions based on the Laplace transform system analysis. Okay, determine the unit step response of LTI system defined by. Okay, so now we have to understand it very clearly. Now they have given the system, they have defined the system with the help of differential equation. Okay, anyway, from this differential equation, we can get what is h of t somehow. Okay, because we can calculate what is h of s, then we can get what is h of t. Okay, then what do you mean by unit step response? Okay, response means output. Okay, response means output. What is the output when you provide unit step as the input? Okay, so they are mentioning the input is equal to unit step. Okay, so that is the that. So we have to find out the response due to the input, that we will call it as a unit step response for the given LTI system. So now first we'll try to find out h of t. Okay, and then we know what is u of t. Then we'll operate on the s domain. Then later we'll get y of s. From y of s we can get y of t. So what is the procedure? First we have to find out what is h of s. Okay, then we know that h of s multiplied with x of s is equal to y of s. Then once if you take inverse Laplace transform for this one, then we can get y of t. We can get y of t. So now from this given differential equation, we'll try to find out h of s. Okay, then here they are not given any initial condition, so directly we can utilize this formula. Okay, without any initial condition. Then second order differentiation means replace with s square ys s square ys plus 5 s ys plus 6 ys is equal to d by dt means yes. Again, this is x of t. Okay, so maybe they forgot to mention this is x of t. Okay, so again, what is the d by dt is yes. What is the Laplace transform of x of t? That is x of s. X of s plus x of s. Okay, so from this we can take x of s outside, so that this is s plus 1. From this side we can take y of s outside, so that this is s square plus 5s plus 6. Now we have to find out h of s. H of s is equal to y of s divided by x of s. Okay, so h of s is equal to y of s divided by x of s, that is s plus 1 divided by s square plus 5s plus 6. Okay, so now what we have to find? We have to find y of s. Y of s is equal to h of s multiplied with x of s. Again, we have to find out what is x of s. Anyway, they given x of t. Okay, x of t means what? Indirectly, they given x of t. That means they are asking unit step response. That means what is the response when you apply unit step as the input. Okay, so for this x of t, if you take Laplace transform, that is 1 by s square. So now we know what is x of s. Already we know what is h of s. Sorry, I think yes, we made a mistake here. The Laplace transform of u of t is 1 by s. Okay, then h of s is there, s plus 1 divided by s square plus 5s plus 6, okay, into s into s. Now we can apply the partial fraction. Okay, then if you do the partial fraction here, again we can find the factors for this. This is s into, again the factor for this is s plus 3 into s plus 2. Okay, then y of s we can write like a by s plus b by s plus 3 plus c by s plus 2. Okay, already we have seen many situations like this, so directly I will write abc value. Okay, y of s is equal to 1 by 6 divided by s minus 2 by 3 divided by s plus 3 plus 1 by 2 divided by s plus 3. If we take inverse Laplace transform, then y of t is equal to 1 by 6 u of t minus 2 by 3 e power minus 3t u of t plus 1 by 2 e power minus 3t u of t. Again, one thing please remember here we will not have any ROC, because it's always implied whenever we discuss about, whenever mostly we discuss about the LTI system, a linear time invariant system, and also the systems and all physically realizable, so that in general it will be defined only for positive time. Okay, u of t. That's why it's always implied. Okay, the ROC is towards right side. ROC is towards right side. That's why in general we used to write u of t instead of u of minus t. Okay, so whether whenever they define about the system, mostly they will not be giving you the ROC. Okay, that is always implied. Okay, the given system is a causal system. Okay, then yes. Okay, then what about the next question? Next, an LTI system is represented by this differential equation with initial condition y of 0 is equal to 0, y dash of 0 is equal to 1. There are two initial conditions, in that one initial condition is having 0. Okay, then other is having value, but in some other cases we may be getting both value. Okay, both value without 0, both may be of some value, it may be positive or negative. Then find the response of system when the input is x of t is equal to e power minus t ut. Again, we know that whenever the initial condition is given, d square by dt square can be replaced by like this: s square y of s minus s y of 0 minus y dash 0. Again, s square y of s. What is the value of y of 0? That is 0. So 0 into s minus 1. That means y dash of 0. Okay, what is y dash of 0? That is 1. So again, this can be simplified like this: s square ys minus 1. Then what about the first order differentiation? This is s into ys minus y0. Again, y0 is 0. So s into y of s. Okay, so now we'll do this replacement. Then we'll try to find out h of s. Okay. So s square y of s minus 1, okay, plus 4 s y of s plus 4 y of s. Okay. Then which is equal to x of t means x of s. Then take the y of s outside. Y of s is equal to s square 4s plus 4. This minus 1 will be there separately. This is x of s. Okay, y of s is equal to s square plus 4s plus 4. Okay, then this is equal to x of s plus 1. Okay, so uh, again, either we can find out what is h of s, or otherwise we can also see finally what we need. Finally, we need what is the output due to this input. Okay, so now that input I can directly substitute here also. That means what? X of t is given as e power minus t u of t. Then what is the Laplace transform of this one? X of s equal to 1 by s plus 1. So that I can substitute that here directly. Okay. Now what will happen? 1 by s plus 1 plus 1. That means s plus 2. In the numerator you will get s plus 2 divided by s plus 1. Again, this y of s I can take here. This factor I can bring down. That is s square plus 4s plus 4. Okay, so this again further I can simplify. Okay, I can write in terms of factor, that is s plus 2 divided by s plus 1. This is s plus 2 whole square. Okay, this is s plus 2 whole square. Again, already s plus 2 is there in the numerator, so that 1 s plus 1 into s plus 2. Again, apply the partial fraction now. Y of s is equal to 1 by s plus 1 s plus 2. We have seen this situation, so directly I am writing a by s plus 1 plus b by s plus 2, where a value is 1, b value is minus 1. Then if you take inverse Laplace transform, then y of t is equal to e power minus t ut minus e power minus 2t ut. Next question, an LTI system is defined by differential equation. Find the response of the system, that is y of t, for the given input. Now the input is u of t. That means they are asking unit step response with the initial condition y of 0 is equal to 1, y dash of 0 is equal to 2. Okay, and we know that whenever initial condition is there, d square by dt square can be replaced by s square y of s minus s y of 0 minus y dash of 0. That means s square y of s minus s, because y of 0 value is 1, and then y dash of 0 is 2, the 2 is here. Then similarly for dy by dt, s into y of s minus y of 0, so s into y of s minus 1. Then s square y of s minus s minus 2 plus 4 s y of s minus 1 plus 5 y of s is equal to, that is the this side only x of t, so this is x of s. Now take y of s separately. You will be getting s square plus 4 plus 5. Okay, then this here you will be getting minus s minus 2. From this you will be getting minus 4. Then already x of s is there. Okay, so now y of s is equal to y of s square plus 4s. This is 4s. Okay, 4s plus 5. All these terms I can take right side. That is x of s plus s plus 6. Okay. Then again we know what is x of s, because x of t is equal to u of t. Okay, x of t is equal to u of t. Then that means what is x of s? Okay, x of s is equal to 1 by s. Okay, that we can substitute here. Okay, this is 1 by s. plus s plus 6. Okay, then you will be getting s square 6x plus 1 divided by s. Anyway, here already we are having y of s square 4s plus 5. Okay, then we can take this term downside. Y of s is equal to s square 6x plus 1 divided by s into s square plus 4s plus 5. Okay, so now we can, I'm just writing this term first, s square plus 4s plus 5 into s. Okay, so now this term, this s square plus 4s plus 5, we cannot do the factor easily because it will be giving you the complex number. Again, we know that whenever complex number is there for a partial fraction technique, we will be using ax plus b, that means as plus b divided by s square plus 4s plus 5. Then here we will be getting c by s. Okay, this c we can get directly. Okay, just by substituting s equal to 0 here, we can get c directly. But a and b we cannot get directly. So that now you take this numerator here, s square plus 6x plus 1, then you cross multiply this, then you will be getting as square bs. Again, if you cross multiply this here, you will be getting cs square c4s and then 5c. Okay, again, just you take the s square term separately, that means a plus c s square, and then s term separately. Okay, that means b plus 4c into s, then finally constant. Okay, again, constant is equal to constant, that is 5c is equal to 1. So from this easily we can tell c is equal to 1 by 5. Okay, again, similar to this, b plus 4c is equal to 6. Okay, b plus 4c is equal to 4c is equal to 6. Now we know what is the value of c. Okay, that you can substitute here. Then from this we can find out what is b. So b is equal to 26 by 5. And then from this term, a plus c is equal to 1. Okay, next a plus c is equal to 1, and then you know what is the value of c. Okay, that means a plus value of c is 1 by 5. Then we can calculate what is a, that is 4 by 5. Okay, so now we know value of abc, so that y of s is equal to as plus b divided by s square 4s plus 5 plus c by yes. Okay, so now write that value. A is equal to 4 by 5 yes, plus b is equal to s square 4s plus 5, then c is equal to 1 by 5 yes. Okay, again, finding the inverse Laplace transform for this second term is easy. Again, this is a little bit tricky because in the numerator we are having plus. Okay, so that we will separate this. Okay, we will write separately 4 by 5 into s divided by s square 4s plus 5, and this as, I think this is not b value we know, the b value is 26 by 5. Okay, so this we can write like 26 by 5 divided by s square 4s plus 5. Okay, again this is 1 by 5 divided by s. Okay, so now y of s I have written in terms of three different component, but that too with the function of s. So that what I can write here, because finding the inverse Laplace transform for this one is not straightforward. For the third term we can write easily, but for these two we cannot write that much easily now because some concept is there. Yeah. So now I'll write y of s is equal to x1 of s plus x2 of s plus x3 of s. Okay, then I'll take the inverse Laplace transform, then this is y of t, this is x1 of t plus x2 of t, and then plus x3 of t. Okay, so now we'll take x1 of s, then we'll try to find the inverse Laplace transform. Okay, what is x1 of s? X1 of s is 4 by 5, okay, 4 by 5, s divided by s square plus 4s plus 5. Okay, so again, this is the denominator is having second order. That means this is something related with Laplace transform of sine or cos. But even in the numerator, we are having s. And once if the numerator is having x, yes, and denominator is having s square, then that means this is the Laplace transform of cos omega t. See, for example, when Laplace, what is cos omega t? Okay, cos omega t means s divided by s square plus omega square. And again, omega is a number. Okay, if it is a number, again, here also you are going to get the number. But again, with some extra factor, okay, with some extra 4s is there, some extra components are there. So that means what, suppose, for example, when you have a like this Laplace transform of e power minus at cos omega t, then what you will be getting, s, okay, s plus a divided by s plus a whole square plus omega square. So now we'll try to write this equation in terms of this format. Then directly we can write the inverse Laplace transform. Okay, so now I'm going to just modify this. Okay, so this is again 4 by 5, 5 divided by s square plus 4s. I am introducing one number here, that is plus 4 minus 4, like this. Then already plus 5 is there. Then by taking the first three term, I can write like x plus 2 whole square. So that this is 4 by 5, 5 by s plus 2 whole square. Then what I am getting, 5 minus 4 is 1. So that this I can write like 1 square. Okay, 1 square. Okay, then finally x1 of s, x1 of s is equal to 5 divided by, okay, what is that constant, 4 by 5, 4 by 5, 5 by, sorry, it's not 5, this is yes. Yes, yes. Okay, s divided by s plus 2 whole square plus 1 square. Again, now what is missing here? We have denominator we have written in this format. Again, numerator also we should write in the format of s plus a. Okay, whatever a is there, same a we will try to bring here. So then I will add 2, then subtract 2. Okay, now I will be getting this format. Okay, so finally I will write like this, s plus 2 divided by s plus 2 whole square plus 1 square. Then that 2 I will write separately, 2 divided by s plus 2 whole square plus 1 square. Now what is the inverse Laplace transform? That is 4 by 5. Okay, if it is of this format, e power minus 2t, okay, cos omega t, omega value is 1, so this is cos t. But if you concentrate here, this is something like Laplace transform of e power minus at sine omega t. Okay, then what you will be getting, simply 1 by s plus a whole square, then omega square. Okay, then you take this minus 2 separately, then apply the inverse Laplace transform for 1 by s plus 2 whole square plus 1 square, then you will be getting e power minus 2t sine omega t, but that omega value is 1, so sine t. Okay, so finally this is the inverse Laplace transform of only this component x1 of s. Similarly, we have to find out what is the inverse Laplace transform for x2 of s and also x3 of s. Later we have to add everything. Okay, then what is the inverse Laplace transform of the second component, that is x2 of s? Okay, x2 of s is equal to 26 divided by 5, 5 divided by s square plus 4s plus 5. Okay, this I can write like 26 divided by 5, s plus 2 whole square plus 1 square. Again, now easily I can write the inverse Laplace transform. X2 of t is equal to 26 divided by 5. Okay, 26 by 5. Again, this is e power minus 2t sin t. Sin t. Again, everywhere that u of t will be there. Okay, everything is always multiplied with u of t. Even this also multiplied with u of t. Then finally, what is the Laplace transform of the third component, that is x3 of s is equal to 1 by 5 s. X3 of t is equal to 1 by 5 u of t. 1 by 5 u of t. So now we will add all x3 of t, sorry, the output. Okay, so I think here you could have used the different notation, because y of s we are getting like this. Okay, so it is better always to use in terms of y. So that means y1 of s plus y2 of s plus y3 of s. Similarly here, y1 of t, y2 of t, y3 of t. Here y1 of s, here y2 of s. Okay, y2 of s. This is y3 of s. y3 of t. Okay, so now we need final y of t, that is equal to y1 of t plus y2 of t plus y3 of t. What is y1 of t? This is that's something we have written wrong, I think. This is y1 of s. Okay, y1 of s, so that this is y1 of t. Okay, so what is y1 of t? Okay, so this entire expression is the y1 of t. So 4 by 5 e power minus 2t cos t minus 2 e power minus 2t sin t. Okay, this 4 by 5 I will apply inside. Okay, so directly 4 by 5, 4 by 5 e power minus 2t cos t, e power minus 2t cos t, then 4 into 2 minus 8 by 5, minus 8 by 5 e power minus 2t sin t. Okay, y1 of t we have written. What about y3, y2 of t? This is y2 of t, 26 by 5 e power minus 2t sin t. Okay, so 26 by 5 e power minus 2t sin t. What about y3 of t? Is simply 1 by 5. Again, everything is having u of t, so that I will put that u of t common outside. Okay, if you concentrate on here, the second and the third component, both are having same structure, e power minus 2t sin t. This one is also e power minus 2t sin t, so that I will add these two. So 26 by 5 minus 8 by 5. Okay, we'll be getting 18 by 5. Okay, this is 18 by 5. Okay, final answer is 4 by 5 e power minus 2t cos t plus 18 by 5 e power minus 2t sin t plus 1 by 5 finally u of t. Okay, this is the output for the given system. Okay, thank you.